Alright, so part 3 video of 8.7, we're going to be talking about Simpsons Rule. Simpson Rule has subintervals grouped in pairs, so n has to be an even integer. And here we're not going to use rectangles or trapezoids, but we're going to use parabolas passing through the 3 points on the pair of our subintervals. So if we look at a graph, so in red, you got to be kidding me, I didn't even touch my mouse. In red, that's my function curve. Really crazy. But it's continuous on the interval from A to B. I'm going to take x sub 0, x sub 1, x sub 2. I'm going to find those y coordinates. And we are going to build the best possible parabola through those 3 points. And then this interval, subinterval, we're going to use x sub 2, x sub 3, x sub 4. And again, we're going to make the best parabola that matches for that subinterval. And then the last one here, take these last three, x4, x sub 5, x sub 6, create that parabola to find the area under that curve. All right, so the formula for this is this approximation is now b minus a divided by 3n. All right, so if you remember, I believe the midpoint was n, trapezoid was 2n, and now the Simpsons rule is 3n. And the next thing I want you to notice is that the first f of x sub 0 and the last f of x sub n, or in this case f of x sub 6, nothing's multiplying to it, just like it was in the trapezoid rule. But now everything in between, it's not multiplied by 2, they literally alternate. So 4 times f of x sub 1, 2 times f of x sub 2, 4 times f of x sub 3, blah, 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 blah. No matter what happens, because you're using an even number of subintervals, you will always get 2, 4, and the last term at the end. It will never be a 2 here. It's always going to be a 4 being multiplied to that height, or that f of x sub n minus 1, or in this case, f of x sub 5. And again, as I talked in the previous video, your air-bound rule. Now, this is where it is really crazy. Your air, whether it's positive or negative, for Simpsons rule, less than or equal to b minus 5 to the 5th power over 180 to the n to the 4th power times, get this, they want you to find the max of the 4th derivative of that function on our bounds from A to B. Okay, that's why we're not having this on the test. All right, so let's do our same problem. 1 over 1 plus x to the 6 from 0 to 2, now using Simpsons rule where n is equal to 8. So based on the formula, there it is. Da, 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 da. B is 2, a is 0, so that's 2. 3 times 8, that'll be 24. And we need to find f of 0. Now remember, in the previous examples, our change in x, our width was 0.25 or 1/4. So it's going to be 4 times f of 0.25 plus 2 times f of 0.5, 4 times f of 0.75, all the way up to until we get to f of 2. And as you can see, it's going to end with a 2, 4, and then your very last x sub n. And I'm going to bring this back. You still have it in your table. These are my table of values. So we use the x sub I and the f of x sub I. That was for the trapezoid rule, but we're going to use the exact same values for the Simpsons rule. Now, the one thing we have to do different here is we got to say, okay, f of 0, nobody gets multiplied to that y. There's a 1 there. And f of 2, no one's multiplied to here. But the second one, the 0.25, this gets multiplied by 4, by 2. By 4, by 2, by 4, by 2, by 4, and nothing. So again, I have absolutely, positively no desire to enter all these decimals just to multiply it by 4. All right, so again, Here's my calculator entry, and I'll bring my calculator up and we'll talk about how to enter it. We are going to create a sequence for all the y's that you have to multiply by 4. And we are going to create a sequence for everything you got to multiply by 2. And remember, we took the 1 and the 2, or I should say f of 0, f of 2, the first and the last entry, we put it in A and put it in B, added it together. Okay, so that's technically right here. So I'll show you this on the screen again. So let me bring my calculator into play and how to enter all this. So again, I still got my function there in y, so it's all in y1. All right, so I want to do a sum and sequence. So we're going to go 4 times second stat under math is the sum function, number 5. Second stat under the ops is your sequence, number 5. So that's going to take you to this window. Now, recall that where is my variable expression? Again, we have it saved in y1, so alpha trace, number 1. What's the variable that we used there? We used an x. What do I want to start with? Well, for the things we want to multiply, let me move this over. Oh, I can't. I got to squeeze this down just a little bit. Okay, just so I can see my numbers here. So take all the ones that are being multiplied by 4. It starts at 0.25, so we put in 0.25. And we're going to end at, well, 1.75. That's the last thing we're going to multiply by 4. And your step, that's what we got to count by. So if I'm going from 0.25 to 0.75 to 1.25, I'm counting by a half, so 0.5. And enter, and then we'll paste it into the home screen. So this is what you see in the PowerPoint. There's my command. All right, so I'll hit enter. There's that total. All right, now let's do the same thing for what we're going to multiply by 2. Now, if you want, you can just jump up here and copy that statement real quick. We'll just go back to the front, change the 4 to a 2. And where am I starting at now? I'm starting at 0.5, so let me go to the 2 and delete that, so it's 0.5. Where do I want to end at with my 2's? At 1.5. So let me delete the 7 on the 1.75, delete. And we're still counting by 0.5. 0.5 to 1 to 1.5. So I hit enter. There's that value. And just to make sure, alpha A, that should still be that. Yep, I still have it saved in my calculator. There it is. So basically what I want to do is just now add these 3 together. All right, so we can just jump up here, or better yet, let's just stay down there and say plus, that's this number, or you can go A, either one you want. So let's clear it out. We had the A, so alpha A plus, let's jump up and grab the number that we're multiplying by 4, plus, and jump up to where we're multiplying by 2, that's this sum. And we add that all together, and you get the 12.506066497. So that's all of this here added together. Now 2 over 24 becomes 1/12. Then we just divide that by 12. And we get 1.0421728081. And that's how we work that on the calculator. Get the exact same number right there. All right? And that's the Simpsons rule. Very closely related to the trapezoid rule, except we have these alternating 4's and 2's.